click on the like button and then you will see a hype button. Then click on that and then hype me to support me. In this video I'll be making para-Tolyl isocyanide via Carbylamine reaction. Isocyanide exists in two resonating forms, linear and bent. The bent form is less stable and more susceptible to polymerization. The stability of linear form can be increased by attaching electron donating groups. Since I didn't have para-anicidine or para-aminophenol, I chose para-toluidine over aniline and para-nitroaniline. Also, phenyl isocyanide has a very strong offensive smell, that is why I chose not to make it. To start the synthesis, I took 1 gram of para-toluidine, 2.5 grams of potassium hydroxide, 1 ml chloroform, methanol for solvent, and petroleum ether for workup. First, I measured 2.5 grams of potassium hydroxide in a beaker. To it, I added 10 ml of methanol and swirled it to dissolve. Then I covered it and kept it aside. Then I measured out 1 gram of para-toluidine. Then, in a 3-neck round bottom flask which had a stir bar in it, I added the para-toluidine and dissolved it in 10 ml of methanol. And then I poured in the methanolic potassium hydroxide solution. Then I placed a rubber septum in one neck and a thermometer was attached in the other neck. It was adjusted so that it is dipped in the solution. The flask was set on a water bath on a magnetic stirrer and it was heated using a spirit lamp. A condenser is attached in the middle neck and a temperature probe was dipped in the water bath to monitor the temperature of water bath. I took 1 ml of chloroform in a syringe and started adding it through the septa in small portions when temperature reached 60 degrees Celsius inside the flask. When chloroform was added, the reaction started turning cloudy, which is due to the formation of salt, which is potassium chloride. This is the overall mechanism of the reaction. First, the chloroform reacts with potassium hydroxide to form dichlorocarbene, which then reacts with the amine followed by two successive elimination of HCl molecules. Isocyanide is formed. The temperature is maintained between 60 to 70 degrees Celsius during the whole addition, and when addition was complete, I checked the TLC of the reaction mixture and you can see that the starting material has almost consumed. Also, the offensive smell of isocyanide was observed when I opened the flask. I let it run for another 15 minutes and then you can see the amount of salt that is formed inside the flask. I then wrapped the flask in aluminum foil and distilled off the methanol. Methanol was having difficulty in distilling and only this much of methanol was distilled off. So I stopped the distillation as I did not want to destroy my product due to high heat and my vacuum pump is out of service. Then I took out the flask from the water bath and added distilled water in it and then added some petroleum ether in it. Petroleum ether would dissolve the isocyanide but not the para-toluidine. I then stopped the flask and stirred it for a minute or so. When stirring was stopped, the petroleum ether layer turned brown. It was transferred to a separatory funnel. The flask was washed with small amount of petroleum ether. The stir bar was taken out with a bead picker and the petroleum ether was transferred to the separatory funnel. The lower aqueous layer was drained off in a beaker, but accidentally some ether layer also went in it. The ether layer was transferred in a conical flask and I stoppered it. I again transferred the aqueous layer back to the separatory funnel and 10 ml of petroleum ether was added. I then capped, shaked and vented, allowed it to separate and transferred the petroleum ether layer into the conical flask. The extraction process was again repeated 2 times. To the conical flask, I added some anhydride sodium sulfate to dry the petroleum ether. I actually added it a lot more than required. Swirled and allowed it to sit. The fourth extraction is very faint colored, means we have extracted almost all the isocyanide. It was also transferred to the conical flask. Then I took a rota joint. This would act as a small funnel, and plugged it with some cotton and filtered it into my 100 ml round bottom flask. I washed the separatory funnel with some petroleum ether and also transferred it to wash the sodium sulfate. I again washed the sodium sulfate with small amounts of petroleum ether until washings became clear. The petroleum ether was distilled off in a hot water bath. Meanwhile, I washed my glassware with a methanolic solution of hydrochloric acid. So I took distilled methanol and added concentrated HCl to it and used to wash my separatory funnel flask. The acid would destroy the isocyanide and remove the nasty odor of it. As the water warmed up, the petroleum ether started to distill off. It distilled off very quickly, but at one point it slowed down. Even when water started to boil, it wasn't distilling over. I stopped the distillation as heating leads to destruction of isocyanides. If I had my vacuum pump working, I would have distilled off at a lower temperature. I then measured the yield and it was 1.53 grams, which is even more than theoretical, which is 1.1 gram, which means it still has petroleum ether left. I thought that my isocyanide had been destroyed, but it still had strong odor of isocyanide, and when I tried it in reactions it worked.